Hi guys, here's your video on section 5.3, solving trig equations. So the first example, we want to find all of the solutions for each of these trig equations, and then as we proceed we will start finding solutions within a specified interval. So for letter A, I have 4 sine squared of theta minus 1 equals 0. I'm going to isolate my sine of theta because I'm trying to solve for my angle. So I'm going to start by adding 1 to both sides. So I have 4 sine squared of theta equals 1. Divide both sides by 4. I get sine squared of theta equals 1/4. And then since I'm solving for sine, I'm going to go ahead and take the square root. So I have sine of theta equals plus or minus, because I took the square root. Square root of 1 is what? Square root of 1 is 1. Square root of 4 is 2. Now here's what I'm looking for. I'm trying to solve for theta. So I'm looking for all of the angles. When I take sine of that angle, gives me a plus or minus 1/2. So sine is my y-coordinate. So what I'm looking for is I'm looking for when my y-coordinate is a positive 1/2 and a negative 1/2. So my y-coordinates, I have a positive 1/2 in the first quadrant and the fourth quadrant. And I have a negative 1/2, actually I said that wrong. My y-coordinate's positive in the first quadrant and the second quadrant, and my y-coordinate is negative in the third and the fourth. So there are 4 angles that I'm looking for. I'm going to resort back to my hand trick. So my hand trick, I need to find when my y-coordinate is 1/2. So my y-coordinate is 1/2 when I put my ring finger down, so that's at pi over 6. So the pi over 6 gives you this angle measurement right here. So I have pi over 6. So that's my first angle measurement. Since this is my reference angle, that means this measure is also pi over 6. So is this one, and so is this one. So the angles I need to find is this. I have the pi over 6. The next one I need to find is this one. So that's going to be pi minus pi over 6, which is 5 pi over 6. The next one, which I'm going to do in purple, needs to be this angle. So that's pi plus pi over 6, which is 7 pi over 6. And then finally, that fourth angle is starting from my positive x-axis going all the way around. So that's 2 pi minus this wedge, which is pi over 6, so that's 11 pi over 6. Okay, now since we want to find all solutions, there's actually an infinite amount of angle measurements that I can use that would work for this equation, because I could keep going round and round that unit circle with that reference angle of pi over 6 and still get a solution. So the way that we write all solutions is we have these angles, and then you're just going to add 2 pi n to each of them. And I'm adding 2 pi n because 2 pi is a full rotation in radians. And these 4 expressions make up your solution. Alright, let's do another one. So I have 2 cosine of x plus the square root of 3 equals 0. I'm going to go ahead and solve for cosine of x. So I have 2 cosine of x equals negative square root of 3. Divide by 2. So I have cosine of x equals negative square root of 3 over 2. So cosine is my x-coordinate, and my x-coordinate is negative, because this needs to be negative, in 2 quadrants. It's in quadrant 2 and quadrant 3. So the first thing I want to find is that reference angle where my x-coordinate is root 3 over 2. So I'm going to use my hand trick. My x-coordinate is root 3 over 2 at pi over 6. So this reference angle is pi over 6, and this reference angle is also pi over 6. Now the angles that I actually want to find are these two. The blue one and the purple one. So for the blue one, I'm going to take pi minus my reference angle. So pi minus pi over 6 gives me 5 pi over 6. For the purple, it's pi plus pi over 6, which is 7 pi over 6. And of course, since I'm trying to find all of the solutions, I'm going to add 2 pi n to both of those answers. If you are confused on the hand trick, I would recommend that you watch those videos again on finding exact values of trig functions and using the hand trick. It'll make this lesson a lot easier if you're really good with that hand trick. Okay, so cosecant of theta equals root 2. Now, I don't like dealing with cosecant. Instead, I want to deal with sine, because cosecant and sine are reciprocals of each other. So cosecant, if cosecant is root 2, that means sine of theta is 1 over root 2, which is root 2 over 2. So sine is my y-coordinate, and my y-coordinate is positive in the first quadrant and the second quadrant. So I need to figure out what this reference angle is that gives me a y-coordinate of root 2 over 2. That's pi over 4, using my little hand trick. So here are the two angles that I need. I need this one, and I need this one. And by the way, this wedge right here is also my reference angle, which is pi over 4. So my first angle, the blue one, is just pi over 4. And my second one is going to be 3 pi over 4. And since I'm trying to find all solutions, it's plus 2 pi n. Alright, tangent. So tangent is negative root 3. Tangent is negative in 2 quadrants. Just to refresh your memory, tangent is your y divided by your x. So you're looking for the quadrants. When you divide your x and y's, gives you a negative value. That is this quadrant and this quadrant. So the reference angle where I get tangent being root 3 is going to be pi over 3, because that's my y-coordinate divided by my x-coordinate. So I'm trying to find where, when I divide my y divided by my x, gives me root 3. And then that is at pi over 3. So that makes this angle pi over 3, and this angle pi over 3 as well. So the first angle I want to find is this one in blue. The second angle I want to find is that one in purple. So I have x equals, so I'm going to use x instead of theta. But my blue one is going to be 2 pi over 3, because I'm taking out that wedge, plus 2 pi n. And then my purple one is 2 pi minus pi over 3, which is 5 pi over 3, plus 2 pi n. And there you go. Alright, let's do another one. So I have 2 sine squared plus 3 sine of theta plus 1 equals 0. Anytime you have both a trig function that's squared and the regular trig function, you're going to have to factor it. So if you have a sine squared with a sine or a cosine squared with a cosine, you're going to have to factor. Now I'm actually going to do this on the side over here. I'm going to factor this problem as if it were 2x squared plus 3x plus 1. So instead of having my signs, I change them to x's to help me factor it. Since I have a number in front of x squared, I'm going to multiply my first and my last, so 2 times 1 is 2. I'm trying to find two numbers that multiply to 2 and add to 3. That's 2 and 1. So I have x plus 2, x plus 1, but since I started by multiplying by 2, I need to divide both of these numbers by 2. So now I have x plus 1, and for this one, since my 1/2 is already reduced, I can just take this denominator and bring it to the front. So that's 2x plus 1. Okay, so our original problem didn't have x's, it had sines. So I can factor this to sine of x, or sine of theta, plus 1, times 2 sine of theta, plus 1, equals 0. So I have two expressions. I'm going to set them both equal to 0. So I have sine of theta plus 1 equals 0. 2 sine of theta plus 1 equals 0. For this first one, my sine is equal to negative 1. For my second one, my sine is equal to negative 1/2. Subtract 1, divide by 2, so negative 1/2. So sine is my y-coordinate, and my y-coordinate is negative 1 right here. So the angle measurement that I need to find is this one right here in radians, which is 3 pi over 2. So that means for this first equation, it equals 3 pi over 2 plus 2 pi n. For my second one, I'm looking for when my sine is negative. Sine is my y-coordinate. My y-coordinate is negative in quadrants 3 and 4. I'm going to go ahead and find these two reference angles. So sine is my y-coordinate. My y-coordinate is 1/2 at pi over 6, which makes this wedge pi over 6, makes this wedge also pi over 6. And here are the two angles that I'm looking for. I have this one for the blue and this one for the purple. So for the blue, that's pi over 6 past pi, which is 7 pi over 6 plus 2 pi n. And for the purple, that's pi over 6 less than 2 pi, which is 11 pi over 6 plus 2 pi n. So all three of these expressions that I've circled in black give you all of the solutions for your trig equation. The next thing we're looking at is solving for multiple angles. If you look inside these parentheses, you don't just have an x, you have a 3x, and then over here you have a 2x. I'm still going to solve this like I normally did with the other ones. So I'm going to isolate my cosine. So I'm going to add 1 divided by 2. So I have cosine of 3x equals 1/2. Still going to proceed like I normally do. Cosine is positive in these two quadrants because cosine is my x. My reference angle, so my x-coordinate, using my hand trick, equals 1/2 at pi over 3. So that makes this wedge pi over 3, and this wedge also pi over 3. So when I write this, I'm going to write this as 3x equals, my first angle is this one in blue, which is just pi over 3. So I have pi over 3 plus 2 pi n. My second angle that I'm going to do in purple is going to be 2 pi minus pi over 3. So I have 3x equals, 2 pi minus pi over 3 is 5 pi over 3 plus 2 pi n. Okay, now I still need to solve for x, and right now my x is being multiplied by 3. So to undo that, I'm going to divide each of these expressions by 3. So now I have x equals pi over 3 divided by 3 is pi over 9 plus 2 pi over 3n. For my second one, I have x equals 5 pi over 3 divided by 3 is 5 pi over 9 plus 2 pi n. And this is your final answer. Alright, let's do another one. So I have cosecant of 2x minus 2 over root 3 equals 0. I'm going to get my cosecant by myself, or by itself. I guess I am doing it by myself also. I'm going to add 2 over root 3, so that's 2 over root 3 to both sides. And again, I don't like working with the reciprocals. I like to work with the original. So if cosecant is 2 over root 3, that means sine of 2x is root 3 over 2. So sine is my y-coordinate. My y-coordinate is positive in these two quadrants. I have to find my reference angle where my y-coordinate is root 3 over 2, and that is at pi over 3. Use your hand, using your hand trick. Okay, so my first angle is this one in blue, which is just pi over 3. So I have 2x equals pi over 3 plus 2 pi n. And for my second expression, I'm going to use this angle that's in purple, which is pi minus pi over 3. So I have 2x, pi minus pi over 3 is 2 pi over 3, plus 2 pi n. Now I need to get my x by itself, so I'm going to divide each of these expressions by 2. And that leaves me with x equals pi over 6 plus pi n, and x equals 2 pi over 6 plus pi n. Oh, 2 pi over 6 can be reduced. Let's reduce that. 2 pi over 6 reduces to pi over 3. And these two expressions together give you your final answer. Okay, now let's solve using an interval. So it says find all the solutions of the equation in the interval from 0 to 2 pi. So over here I have sine cubed x equals sine of x. Like I said before, anytime you have a trig function raised to a power and a regular trig function, you're going to have to factor it. So let's go ahead and factor this expression. I'm going to get it equal to 0. So I have sine cubed minus sine of x equals 0. I can take out a sine. So that's sine of x times sine squared x minus 1 equals 0. This right here is a difference of squares. So I have sine of x times sine of x plus 1, sine of x minus 1 equals 0. So I have 3 factors, so I'm going to set up 3 equations. So I have sine of x equals 0. Sine of x plus 1 equals 0. And sine of x minus 1 equals 0. So for this first one, I'm looking for when my y-coordinate is 0, so sine of x equals 0. My y-coordinate is 0 right here and right here. So my angle needs to go from 0 to 2 pi, so my first angle for x is at 0. That's this one right here. And my second angle for x is this one, which is pi, so 0 and pi. So there are your angles for your first equation. For your second equation, I have sine of x equals negative 1. So my y-coordinate is negative 1 down here. So that angle measurement is 3 pi over 2. So there's another solution for x. And then finally, for this one, I have sine of x equals 1. So I'm trying to find when my y-coordinate is 1, which is up there, and that is at pi over 2. So x equals pi over 2. So all of these angles together make up your solution. Now if you'll notice, I didn't have to add the 2 pi n to it, and that's because you're not trying to find all of the solutions. You're trying to find the solutions within this interval from 0 to 2 pi. So you don't have to add that plus 2 pi n at the end. Alright, one more. I'm going to subtract 3, divide by 4. Actually, this question has a typo. Shoot. Otherwise it doesn't work out. Let's change that plus 3 to a minus 3. There we go. Okay, so I'm going to add 3 divided by 4. So I have cosine squared of x equals 3/4. I'm going to take the square root. So I have cosine of x equals plus or minus square root of 3/4. So that leaves me with cosine of x equals plus or minus. The square root of 3 we don't know, but we do know the square root of 4, it's 2. So I'm looking for when my x-coordinate is a positive or a negative root 3 over 2. So your x is positive or negative in all 4 quadrants. My x-coordinate is root 3 over 2 when my reference angle is pi over 6. So that makes this pi over 6. This is pi over 6. That is pi over 6. And that's pi over 6. So my first angle is just pi over 6. That's this one. My second angle, which is going to be in blue, is 5 pi over 6. My third angle that I'm drawing in purple is 7 pi over 6 because it's pi over 6 past pi. And my last angle is this one all the way around in black, and that is, that is 11 pi over 6. And those 4 angle measurements make up your solution. Alright, so that concludes your notes for section, what is this? 5.3, solving trig equations.